live at the 2019 Wolfram Technology Conference. I'm Sylvia Haas, and I'm Wolfram Alpha on Twitter. And I'm here with my co-host.
Hi, I'm Rachna. I'm a junior at the Illinois Math and Science Academy, and I'm part of the Wolfram Emerging Leaders Program. We're here with Etienne Bernard, who is the lead architect at Wolfram.
So what do you do at Wolfram? What's your day-to-day?
Okay, I mean by day-to-day. It's a broad question. But basically we're building machine learning functions for the Wolfram language. And so this includes some high-level tools. So these kind of automatic machine learning functions that can be used by everyone. And then low-level functions. So mainly it's a neural network framework that we develop. And then we use this tool to do applications ourselves that we also put in the language. Things to identify an image, to recognize speech, like this sort of thing. Think natural language processing as well. And we also try to take applications that have been done by others and we put them in a repository of neural networks. So yeah, that's mainly what we do.
Okay, so what are you doing at the conference?
So at the conference, I'm going to talk about some high-level machine learning tools, but actually how to use them in an advanced way. Because you can use them in a full automatic way, but you can also tune a bunch of things. And often people don't know about it, so I decided this year to talk about that, because I know kind of the nuts and bolts of how to use these functions.
Awesome.
So tell me about what's new in machine learning at Wolfram.
Okay, so I mean there's a bit of new things in the three areas that I mentioned. So on the high-level tools, we worked a lot on unsupervised learning. Because it all started with classic supervised learning function, like how to do classification, how to do regression. But now we're going more to unsupervised things like synthesizing the missing values that are in data set. It's called data imputation. And about detecting anomalies in data. And this sort of thing that require unsupervised learning. And that's one thing. Then we continue to develop this neural network framework. There's a lot to do. It's a big machine, this framework. So still a lot of bug fixing and improving the performance, because for neural network it's very important to have the network running on multi-GPU, for example. Have the latest accelerating libraries, these sort of things. But also there's something we couldn't do before, for example, training generative adversarial network. It's a pretty popular system to basically to be able to generate image mainly. So this is something we can do in our framework. I mean, you will be able to do in version 12.1. And then in the application side, I think one of the big thing, I mean, it's for images, but mostly for text. I think that's where there's the most activity right now. So a function that is called text cases that is able to do named entity recognition, but not just few type of entities, not just city, country, but like hundreds of types. So that's one thing. And find textual answer, which is something that you can give a text, you ask a question, it reads the text, and you try to answer the question than what it read. So that's another application we worked on.
It can understand, it can read it and actually understand what
Exactly, understand the question, understand this text, and give the answer. I mean, yeah. At the moment, it still doesn't understand the same way as we do, so it doesn't work as well as human. But yeah, that's one of the applications we are currently working on as well.
Okay, awesome.
Can you give us an example of one of these?
Okay, so let's start with the unsupervised learning. So this kind of this automatic machine learning function, and what is at the root of all this function is learn distribution. So this is really a function. You give it basically any data, and it tries to capture the distribution of data set that you gave. So here is an example. This is just two-dimensional data, okay, just to understand. So this is basically just a bunch of pairs of numbers, and then it learns the distribution. And all right, that's the distribution. I don't know why this is small, but anyway. And then you can do things like random variates. So this would be, okay, for example, if we do a list plot of the original data, okay, I could create synthetic data. So I could create 1,000, yeah, why not, and do a list plot. And this would be data that are following the distribution. So you see it looks like this one, but actually been generated. Here I can plot the density function of the distribution. And But what's cool is the application you can do with it. One of them is synthesizing missing values. So let's say in this one, x is 5.5, but I don't know why. You will condition this distribution on x equals 4.5, and then you will sample from this condition distribution. And that's how you can impute the missing values. Okay, this is just many missing values that we impute. So anyway, that's one of the things in high-level machine learning. Now we're coming back to more classic unsupervised learning like clustering, because this has been done a long time ago, but we want to refresh that entirely. Well document the method, redo the automation, things like that. Then that's what I was talking before. You will be able to train generative adversarial network with the framework, and it's very interesting, generative adversarial network. So the idea is you have a network that can generate stuff, let's say images, and the way you train it is that you also train something that can recognize, that can distinguish if an image has been generated or is real.
Okay, cool.
And they are competing. So if the generator gets better at generating images, then the discriminator will get better at differentiating the real from the fake. And then the generator uses the discriminator to improve itself, to say, can I find a way to fool the discriminator? And so it's and it's very different to other machine learning where you usually minimize a loss function. Here it's two things that are minimizing their own loss function, but competing with each other. So there's no loss function actually. There's no global loss function for the system. So we thought it would be very hard to do with our framework because it's a very high level thing. So we have this net train, way to and then you have this monitor that you see, but you don't control the training loop. You don't say, you don't have a loop and you say, update this network this way, then update that network this way, and then you can do, we don't have this. And so we thought, well, we'll have to go low level to do GAN, and actually not. So the trick is that it's still only one network, but it's actually two networks inside. And that way, so there's a little bit of tricks such as, okay, that's just this thing we added for the next version of the language, for 12.1. This says that you will train the discriminator 5 times, and then you will train the generator 1 time, and then you will loop. And with this minimal update, you will be able to train GAN in the next version, and that's just one of our things we're playing with. That's a training progress happening. That's a sample that are generated. So you see they're getting better and better and better. This is trying to do digits. And if I stop near the end, okay, this starts to look like real digit. So anyway, so that's something we're excited on. And maybe the last thing I can talk about is the natural language processing applications. So there's been kind of a small revolution in NLP this last year with the arrival of this. So there's two things. One is a transformer architecture. It's a new architecture, so you have networks that can be convolutional, they can be, fully connected, they can be recurrent. This is a new architecture that uses what's called self-attention. This is very powerful for text. And when you combine that with training, let's say, a language model. So a language model is something that is trying to predicting, what's happening next in a text. Try to predict the future of a text based on its past. So it's learning how to write, basically, right? And when you combine these two things, so transformer and training this language model on huge amount of data, you obtain really, really good network that can kind of understand text, and then you can use them for many other applications. And so one thing we did is that we added these networks in our repository. So the famous one is called BERT, done by Google. That's the beast. Another one is called GPT-2. It's done by OpenAI. This had a lot of media around it, media coverage, because it's the best at generating text. So actually, we can try if you want to start. I'm just going to write something, and then the network is going to continue.
Yes.
Do you have an idea what we should?
Something we should write?
No? It can be anything, right? I like to eat chocolates. I don't know. And I don't know. Let's see. So this is the next 100 words that this model generates. So it doesn't necessarily always completely make sense. You can see it's fake, but generally it's what's going on here? there was a little problem, but it seems that it has worked. Okay. Oh, well, it failed for some reason in the middle. He said, I like to eat chocolate and soup, and so I can send him videos of myself practicing in yoga, kumbaya, football, fencing, and playing football. I love practicing monkeys, King Kong. Okay, that's a bit that's a bit weird.
But it knew it was like a bio. It was writing about things that
I
they
guess,
like to do.
yes. It went in this narrow domain
Yeah.
that I like to eat chocolate is probably a sort of
Yeah.
bio thing.
So it doesn't want it to be super long.
Yep. Oh, maybe it was end of. Okay, who knows? All right.
So these models are just trained with like lots of different texts.
Yes. It's like text with billions of words, and I don't remember, and I don't know this particular one. I forgot, but it's like a lot of Wikipedia, a lot of everything, and then so we use. That's another one. And we call it a jade potato curry, which is nice too. Okay, whatever. That's what it generates. But before that, language models were much worse.
Okay.
Okay. And so one of the applications we did using this type of model as preprocessing, let's say, it's something to detect content in a text. So that's what I was mentioning before, name entity recognition, but for various things. So it will recognize country, recognize, let's say, colors, administrative division, quantity, and many other things, actually. It's like hundreds. Can recognize stadium, can recognize, I don't know, field, or I don't know, named, anyway. And then factual answer, that's what I was saying. So you have a paragraph, so it's a small one. How many people live in Paris? And then it try to figure out from the text where the answer is.
That's amazing.
Yep.
So what are the next steps in machine learning?
Okay, next steps. Well, there's many. Although we start to feel like, for example, in the high-level machine learning side, it starts to complete itself. Like we are missing a few things. Something to be good on sequences. To predict sequences well, to find anomalies on sequences, that sort of things. We still need to finish and polish on the unsupervised learning side. Maybe on the reinforcement learning, although it's not a huge application right now, there's a lot of research about reinforcement learning, but in practice it's not something that is used so much. But nevertheless, that's something we could create a high-level function to learn, so you can learn how a robot can walk or these sort of things. And then on the neural network side, there's few things. Actually, I think I wrote them down. Yes, okay, this is things for the neural networks. We try to work hard on having our network be compatible with other frameworks. Because it's often the case that you're in an organization and everybody uses, I don't know, TensorFlow or PyTorch, and you want to be able to still use the Wolfram language, but then export the network or import the network, in this other framework, or export it to, so it works on a phone. Export it to core ML and these sort of things. So we're working hard to support the ONNX format, which is kind of a format for converging networks in other frameworks. Custom layer, that's something I think we'll be able to do, not in 12.1, but in the next version. So you can write arbitrary, you can create your own layers, basically. So anyway, there's interesting things about that. Remote training also, we try to make it, we want to make it very easy to be able, from your laptop, to, let's say, launch a machine on AWS, on Amazon, right? And then put some data also on Amazon machine, and Amazon or something else, and then be able to launch a remote training that we train on powerful GPUs, powerful graphic cards, rather than your laptop. So that's sort of the things we're trying to achieve, at least for the neural network framework.
That's awesome. Well, thank you so much for coming in and sharing with
welcome.
us. This has been really cool.
Yeah.
All right.